Simplifying the design of a self-compacting concrete. I am Professor Dr. Engineer Roberto Rojas Holden. Self-compacting concrete (SCC) is obtained using superfluidifying additive, giving the concrete the properties so that it can be placed by simple pouring. It is in fresh state. It is characterized by a fluid consistency and great resistance to segregation during transport and placement, considerably facilitating the concrete task, increasing construction speed and reducing compaction defects. In the hardened state, can achieve also a higher mechanical strength than conventional concrete. Work development. The SCC has two fundamental differences in terms of the way it is dosed compared to conventional concrete (CC). The main objective is to achieve self-compatibility characteristics rather than meeting a certain strength. Self-compatibility generally defines the coarse aggregate content, the paste volume, the amount of additive, and the water-fine ratio, materials ratio. The strength requirement can be achieved through the appropriate combination of the materials that make up the test. We use additive superplastifier from 3rd or 4th generation polycarboxylates. Designing method. The method decided was from the AC 211, and we did it this way because to facilitate the design methodology. As a result, we have to use the test and pass all the tests of with the cone of Abrams, the L box, the B funnel, and the Japanese ring. Initial consideration: we have to the additive manufacturer's instructions, we have to the European guidelines, and we use the AC 211 method, and we use some assumptions that were confirmed through further investigation, not only this research but about 10 research with many other additions and additive. So we use high range water reducer, but at 5%, because 40% is for strength, not for high fluidity. And we use also a size of 19.1 millimeter. And we consider fixed two values: a settlement of 18 centimeters in the table of ACI 1211, and 50% of the volumetric weight of concrete in the table 5 of the AC 211. The initial data are the same that from conventional concrete: granulometry, fineness module, diameter, maximum diameter, and also the unit mass of dry and coarse aggregates, the density, the dye density of the materials, the absorption and the humidity of the materials, and we use a characteristic strength of 300 kilograms per square centimeter, or 30 megapascals. We with a aggregate size 90 millimeters, fineness module of the fine aggregate 2.4, cement density, coarse aggregate, fine aggregate, sand fine density, and chemical and mixture density, as also as the other coarse aggregates. The water consumption for square meter, on table 2 we use for the 19, I say this 19 to 200 to 18 centimeters here, with 19 216 with 2% or 20 liters of air. So here we use 260, and with a 5% of reduction with the additive, we did it with 205 kilograms of water per square meter, cubic meter. So we use the ACI with to the characteristic we added 85, so we have 38.5 megapascals for media strength. We also have the water cement ratio for 385, so we made an interpolation between 420 and 350 and between 0.41 and 0.48. That gives us well, in the next set of table 5 we fix this number. Doesn't matter, we have the finest module was not 2.4 exactly, but we can use for any module from 240 to less, even because we have our sun is not so don't have very much high finest module. So if we use different sizes of the aggregate, of the coarse aggregate, also will be 0.5, 50% the volume of coarse aggregate. So that was fixed. That is our method, and we did it with the funnel, the L box, the Abrams cone, and the Japanese ring. And the water cement ratio finally was 0.45, the volume drive 50%, as I said, the water 205, and also we did it with the equation to resolve the equation. The dry mass for 90 millimeters brittle, 746, from brittle 9.8 millimeter, 392, sand 541, cement, and in this case without addition, 467, water 205, and mixture 7 kilograms for for characteristic 300. So we use this super plastifier B, the polycol carboxylate. Cell compactness, we also do the test, and the results were what we see here. The funnel 8 seconds, the flow settlement 4 seconds for 50 centimeter of diameter, and final diameter 70 centimeters. The L box 1.5 seconds to 20 centimeters, and to 40 3.5 seconds. And the high relation between high 2 and high 1 0.8, and the O ring or J ring 65 centimeters. So we have the guidelines with the European guidelines. We have also very good results by weight, 5441 inside the European guidelines. The pace, the volume 360 between the European guidelines, 205 between the European guidelines. The coarse aggregate results by weight 745, very near the European guidelines. Fine aggregate more than 48% inside the guideline, and 1.12 very near the European guideline. We also classified this by SF2 by the same European guideline, because to improve the segregation, the classification, walls and columns. Conclusion: it is feasible to do self-compacting concrete with this methodology, and its main advantage is the saving in time and number of mixtures to ensure that the concrete is considered SCC for the strength that is designed. It is essential to use quality materials, including well-graded and suitable fine aggregates, high-quality cement, and specific additives to improve their flowability and workability. The precise dosage of the component is essential to obtain the design characteristics of the SCC. During the preparation of self-compacting concrete, it is important to closely monitor the consistency, workability, and strength of the material. When placing this concrete, factors such as temperature, humidity, and placement time must be taken into account. We have to coordinate with the construction team to ensure quick and efficient placement of the SCC and avoid segregation or loss of consistency during the process. Here are some materials. Sorry, they are in Spanish, but if you will, and this is how you say, you ask me, I could translate it for you. Thank you very much for your attention.